Yeah, welcome back to Gallant Tutors Academy. Yeah, as I told you that in our subsequent video, most of what we'll be treating are the calculation aspect or something that will enhance your ability to solve questions on friction. So welcome back. In today's video, we'll be going further, right? If you are just new, this is the first video, I suggest you probably try to watch our previous video, right, where we talk about the basics. Do you get it? Will help a lot. All right, let's dive in. So as I told you that friction persists, right? There is nothing in this world where there is no friction. I think there is always friction of some kind. Even in airplane experience friction, right, as drag, right, there is always friction. Do you get that? So from the brakes of it on your car to the grooves on your shoe, friction is the constant force, right, everywhere. Do you get that? So this guy delves into this tutorial, this lecture delves into the calculation aspect of friction, equipping you to analyze and predict its behavior, right, in different cases. All right, so we know that friction exists, but now how are we going to tell that okay, since friction exists in every way, how can we quantify it? I guess it. How can we quantify it? Because this is actually very important. If we know that, okay, for me to fly a rocket, I must overcome a certain friction, a certain force. If I don't know that force, it will be very, very difficult for me to actually fly that rocket. But if I now say, okay, to fly this rocket, I must overcome a force of 500 Newton. That means my thrust might be 700 Newton, 1000 Newton, but something above 500 Newton if I intend to escape or to overcome this friction. I guess, and that's when the frictional part of the calculation aspect of friction comes into play. All right. So one of the things which we'll be focusing on is actually the coefficient of friction. The coefficient of friction. Now, what do you understand by coefficient of friction? All right, I'll put it very, very simple so that you don't miss anything at all. So the coefficient of friction is a property that describes how rough or how slippery two surfaces are in contact. Let's assume I have a line here, and let's say a box, right? Right? So I don't really know how this box is going to flow. I'm not aware of that. I get it. Because there is friction between the surfaces. So it's actually coefficient of friction that helps us quantify it, right? Coefficient of friction, just like I've said, is a property that describes how rough or slippery two surfaces are in contact. It is essentially a number that indicates how much friction there is between two materials. Okay, I need you to imagine this thing. Okay, you're trying to push a box, just like this box. You're trying to push this box across. You're applying the force. You're trying to push this force, this box across. The rougher the floor surface, that is, the rougher this place is, right? The higher the friction. I hope you all agree to this, right? The rougher the floor surface, the higher the friction will be, and the more force you will need to apply to get this box moving. The coefficient of friction helps to quantify this relationship, right? We know that the higher the friction, the higher the friction, right? The higher the force you have to apply. So, but this coefficient of friction is what helps us to quantify it. Do you get that? So I like keeping things very simple, right? Let's see what we have on this slide. Now, coefficient of friction is a dimensionless quantity, right? You get to know that very soon. Why is dimensionless, right? I'll bring it back again. I guess, and it represents the proportionality constant, right, between force and normal reaction or normal force. I get it. So it's actually the proportionality constant. You get to see everything very soon. So just like I've said, the higher the coefficient of friction, the greater the force. Of this clear. All right. Now there are actually two types of friction. One is static friction. The other is what? Kinetic friction. Right. So it's actually very. I will explain it in the next slide. Now, static friction. This comes to play when an object is at rest and resists an applied force trying to set it in motion. The ratio of the maximum static frictional force to the normal reaction between two surfaces when they are at rest relative to each other. So it's actually the ratio, right, between the frictional force, right, and the normal force. That's to define it. I get it. So now I like putting it this way: static friction. I told you something at rest. I get it. Okay, now if we have a box here and we are trying to make this box is at rest, I get it. The velocity here is 0, right? The initial velocity is 0. So if we are trying to make this stuff move, it means I multiply a force. But meanwhile, there is actually an opposing force here, right? There's actually an opposing force, right, due to the surfaces in contact. Is that true? I get it. So if I keep on applying this force, right, the force experienced at the point of movement is what is now known as static frictional static coefficient of friction, or static friction coefficient. I get it. So this applies when an object is at rest but on the verge of moving. I get it. Right. So it's representing the maximum force friction can exert before the object starts to slide. Alright, the next one, kinetic frictional force. So kinetic coefficient of friction. Now the word kinetic rings bell in your brain, right? Meaning that it has to do with motion. Probably it's moving or sliding, but it's actually motion. So this applies when an object is already in motion and resists its further movement, right? So it can be experienced that, okay, like for instance, now if I push a box across the span of my room, at some point to stop. That force experience, that quantity or that property experience when the box is about to stop, is what is now known as this kinetic coefficient of friction. So this applies when an object is already moving. Just like I've said, it represents the frictional force that acts to slow this object. So let's assume I push this particular object, I push it this way. So the velocity of this stuff is probably 2 meters per second, right? So at certain point, it will definitely stop. So the property experienced at this point is what is known as what the kinetic coefficient of friction. The K here signifies what? Kinetic. I get it. All right. I would like to say something before I go for normal force. Now, before I usually most students confuses friction and coefficient of friction, and they're like, what exactly do they mean? If I say friction, what do you mean? You say coefficient of friction, what exactly do you mean? Now, let's get it straight here now. Friction is a force. I get it. Friction is the force itself, whereas the coefficient of friction is a property that tells you how much that force there is between two specific surfaces. I get it. Meaning that it's going to differ between the objects involved, but friction is more or less constant. The friction experience is more or less constant because it requires it depends on just one surface. It might be the floor. I get it. It just depends on the surfaces. I get it. So now let's think of it like this. Okay, friction is like weather. It can be sunny, that is meaning low friction. It can be rainy, high friction, or somewhere between. I get it, right? But the coefficient of friction is like the weather forecast, right? Telling you exactly how likely it is to be sunny or rainy. That is low or high friction for a specific location. All that's clear. So friction is the force experience. While coefficient of friction helps predict how strong that force will be based on the material involved. Now let's move on. Normal force. This force acts perpendicular to the contact, to the surface in contact. All right, let's put it this way. Right, it acts perpendicular, right, to the surface in contact. So if you have something like this too, it will also act perpendicular, right, in this direction. Is that clear? So friction, this the normal force, I like calling normal reaction, so you can call it that too. So this force acts perpendicular to the contact surface between two objects, essentially representing the force pressing the object together. Like forces like this, right? The frictional force is facing upward, right? Read this. It's facing upward. So it's actually opposite to what? To the weight. I guess it's opposite the weight, but it's equal to the weight when in the horizontal plane, right? It can be calculated using Newton's law of second law of motion, which is F equal to ma. I get it. So it's as simple as this. In this scenario, this will work, right? In this scenario, that will work. I get it. But not in this. In this particular one, it won't work, right? All right. So it can be calculated using Newton's second law of motion for an object of mass m under the influence of gravity. I get it. All right. So now, so it's just like the previous example, right? When it's like this, how do we quantify the normal reaction, right? So if it's in an inclined plane like this and the angle is this way, right? Though I will explain it in details how we get to how I came about this. I get it. But know this for a fact that when it's on the horizontal surface, right? Normal reaction or normal force is equal to what? Mg. As simple as that. But when it's on an inclined plane such as this, right? So use what? Weight, which is mg, cos theta, because it's an inclined plane, right? Where the theta is the angle of inclination. I get it. All right. Now to the formula. So I told you when we're discussing coefficient of friction, I told you that it actually it's directly proportional to what? Normal reaction or normal force. Exactly. Now the constant of proportionality is equal to what? This. Exactly. All right. Now I also pointed out that this is dimensionless. How do we know? Now, if I to make this such a formula, we have F over N. What's the SI unit of this? Force. Newton. Right? What's the SI unit of this? Which is normal force. Normal force is also Newton. This we cancel this. So this is like what? Dimensionless. Is that clear? Right? So the force here represents the frictional force. This represents what? Coefficient of friction. Why this represents what? The normal force or normal reaction. Is that clear? All right. For each friction, for each specific of friction, that is, if we're talking about the kinetic frictional force or the static frictional force, right? We actually denote this, right? Now we know for a fact that frictional force is equal to what? Coefficient of friction times n, right? Which is normal reaction. This is general stuff, right? But now, if we're talking about if we are referring to the static friction in this case, we can just say, okay, F static, right? Then S representing static here, then just add your S, and then you're good to go, right? If we're representing kinetic, we can just say NF kinetic, right? The coefficient of friction K times the normal reaction, right? Is that clear? All right. So now, most questions which you'll be encountering, right, will require you to draw something. Okay, represent it, right? So that's what we're going to be doing here now. Let's assume we have something of this nature, right? The frictional force is this, the force between the surfaces, right? The exact force between these surfaces, right? Good. Now, the normal reaction. Okay, let's say this is center of gravity. The weight is towards the direction, right? While the normal reaction is facing upward. I can put this R or N, regardless. It's still the same thing, right? So if the frictional force is this way, that means the direction of friction, the direction of force, or the point of movement is actually in this direction. So you can say this is the direction of motion. Exactly. All right. So this is fact. All right. But now it gets complicated when it's on an inclined plane, right? But don't worry, I will explain it very well here. Right. I'll explain it very well here, so you get to understand it. Okay. Let me just show this a bit. Okay, let's assume we have something like this. I'll have a box here. Now, where will it move? It will move in this direction. That means the frictional force is in this direction. So you can say this is our F. This is our F. Now, normal reaction, regardless of the position, is always perpendicular to the surface. So this is our N. Exactly. Good. Now, what are the weight? Weight is like this, right? In the direction of the gravity, in the direction of gravity. So this is our W. Now, how do we know this? How do we know this? How do we know this? Right? Let's put it this way. But let's say these are X. How can we, since N is on an inclined plane, how can we quantify it? It's necessary, right? How do we know that? Oh, okay, good. Right, so we have to, this is how we have to go about it. All right, just let's create another line, right, that is parallel to this. Right, create another line that is parallel to this. So it will be somewhat like this. Oh, not so perfect. So let's see like this. All right, good. Let's manage it this way. All right, so this will be, this is our theta. If this is theta and this is 90, it simply means that this angle is equal to this angle. Is that true? It is 180, right? This is 90. This is 45. This is 45. Exactly. If this is 45, right? Drawing this. So this is what it actually means, that this angle and this angle are equal, right? This angle and this angle are equal, exactly, according to the trigonometric ratios, trigonometric formulas. All right, so I can say here's our y and here's our x, right? Okay, to find x, how do we go about that? So how do we go about to find x? All right, so we know our theta for sure, that is our theta, right? So this is like the adjacent and this is the hypotenuse. So we have adjacent to be x and we have hypotenuse to be w, and we have our theta here, right? Remember, we're looking for x this time around. Okay, now which formula connect them together? Cos theta is equal to what? X over w, which is adjacent. So x is equal to w cos theta, right? So what's our x again? Our x is something as what? Normal reaction. So that proves what I said before, that n is equal to what? Mg cos theta. This w here is the same thing as what? Mg. Don't get it wrong. I get it. All right, now since we've known this, what about frictional force? Because our frictional force is inclined too, and it's affected by this orientation, right? So this opposite, so we have opposite here as our y, and we have hypotenuse, because it has to be relative to what? The weight. So we have hypotenuse, which is w. All right, how do you get about this? So right, so sine theta is also opposite, which is y, over hypotenuse, which is what? W. So our y is equal to what? W sine theta. All right, so take this home. Now this, which I can represent as this normal reaction, like something like this, I can represent as this, the frictional force, is also equal to this, right? So our frictional force, let's then put it as Fr, is equal to W sine theta, or coefficient of friction times normal reaction. That means that if I'm given this, I can just solve it straight, right? Whichever one I want to go with, I can actually get it right. Now let me tell you why this is correct, right? Why this is still correct without the stuff. Now this is equal to what? Frictional force over normal reaction. Is that true? All right, good. So our frictional force is what? I hope you have not forgotten that. What is our frictional force along the surface? Correct. W sine theta. What about coefficient of friction? What is it? I say coefficient of friction. Normal reaction. What is it? W cos theta. I hope you are getting it like this. Very good. W cancel W. Normal. Right? So sin theta over cos theta will give you what? Tan theta. Correct. But now, let me break it down. Like, we don't cram on this channel. Now, sin theta is also opposite over hypotenuse divided by adjacent over hypotenuse. So we have we have opposite over hypotenuse times hypotenuse over adjacent. That is flipping it over. I'm trying to flip it over, right? This will cancel this, so I'm left with opposite over adjacent, right? What does that sound like? Chua! Exactly. So this, bringing it down here, right, is also equal to what? Tan theta. So if, for instance, in a question we're just told to find the coefficient of friction, don't stress your life, don't stress yourself. All you have to do is to use this formula, right? So let's that's just exactly what you are meant to use. Is that clear? All right, let's have a recap. Right, first of all, coefficient of friction. I told you that coefficient of friction is actually the ratio between the frictional force and the normal reaction. As simple as this, right? As simple as this. So it's dimensionless. Don't forget, it's dimensionless. So if, for instance, any question demands that you get the dimension of frictional coefficient of friction dimensionless, right? Dimensionless, which is 1. I get it. All right. So based on diagram, the diagrammatic representation, right, of different scenarios on a horizontal surface. On horizontal surface, we have our normal reaction to be equal to the weight, right? Our normal reaction to be equal to the weight. But now, going over to the inclined surface, it will be different. Is that clear? All right. So N is equal to mg cos theta. I proved that, right? And for coefficient of friction on an inclined plane is equal to what? Tan theta. I proved that too, right? Frictional force is equal to what? Mg sine theta. Exactly. All right. So going over this again, in case you missed out. Coefficient of friction is equal to what? Frictional force over what? Normal reaction. So we have frictional force to be mg sine theta, right? Over mg cos theta. Exactly. Mg cancels mg. Sine theta over cos theta, according to trig ratios, is what? Tan theta. All right. Thank you so much for staying with me up until this time. Remember, thank you for watching. Bye.